Hi everyone. So in this short video series, I'm going to teach you all the fundamentals you need to know to be able to solve recursion and backtracking based problems on lead code. So for recursion and backtracking based problems, there is kind of a thinking pattern. Once you understand that pattern of like how to think for a recursion based problem, any recursion or backtracking based problem becomes very easy. So if you watch this video series to the end, I'm going to give you all the tools you need to solve recursion and backtracking based problems. So I'm going to start from the very basics of what you need to know to solve recursion based problems. So the first thing I'm going to cover in today's video is parameter passing. So before I talk about parameter passing, this is a fundamental which you all know, but I'm still just for you to recollect. A primitive type is basically 8 of these. These 8 are primitive types. So if I do int I equal to 5, I is a primitive type. For reference type, pretty much any reference type you create except for string, you will see the new keyword. Anywhere you see a new keyword, it's a reference type. So here ARR, this is a reference type. Fruit, FR is a reference type. This only string is the one where you don't need a new keyword. You can use a new if you want, but you don't need a new. So S is a reference type. So the difference between primitive and say here if I do int I equal to this and then another one I have int say R, sorry, array, int array R equal to new int. So here the difference between I and R, which is the primitive type and the reference type, is I actually stores the value 5, but this guy does not store the array itself. R just holds a pointer to the location where the array is stored. So this is to do with stack and heap. In one of the next lectures I'll go into more details into that, but for now what you need to remember is this thing, actually this variable stores the memory location. So something like some hexadecimal value AF305B or something like that. That would be the actual value of this thing, which is a memory location on the heap, something like this. So all you need to remember is this guy stores a pointer to this array while I actually holds the value. Primitive types hold the value, reference type hold a reference. So let me pause the video here before the next part of this video. So continuing from where I left off. So I told you the difference between a primitive type and reference type. And this is where that comes into play. So suppose you have a class test. I create an integer int x equal to 3, which is a primitive type, and I do t dot do nothing. So pass this x into here and set x equal to 5 here. And now if I do system.out.println x, what do you think will print? That 5 or this 3? The answer is it will print 3. The reason is what you pass here is just a copy of the value. So when you pass 3 here, then whatever this variable is, that value is what you're changing. This does not change the value in here. So this is for primitive types. Whatever you do in a method, that doesn't affect in the calling part. So this is important, okay? But that is different if you're using a reference type. In a reference type, suppose I create an object called fruit and they say the fruit has a field called name. So I set f.name equal to mango. I do t dot do something, which is this method, and pass in this fruit object. And now if I do f.name equal to something, when I print this out here, what comes out is not mango. It is going to be that thing, something. And the reason is for any reference type, what that variable holds is the address, not the value itself. So that is a key difference to remember. Here x actually holds the value 3 on the stack. We will get into stack versus heap in one of the following lectures. But right now this is enough to remember. This one is actually holding the value. For any primitive type, the variable actually holds the value. But for a reference type, it holds an address location. So this f doesn't hold the fruit object. What it holds is an address, like some hexadecimal value of address on heap where fruit is stored. So when I pass it here, this guy gets the address of the fruit object, and when I change it here, this goes to that address and changes its name to something. So anything you pass for a reference value, you're actually modifying the properties of that object. But for primitive type, it has no effect there. Here, however, one caveat, which some people make a mistake, okay? This is important. If I do f equal to new fruit, if I do this thing, then after that, if I do this, it will not affect this fruit object. In that case, this will still print out mango, because when at the point I do this f is going to point to some other fruit object at some other memory location, not this fruit object. So if you do this, then it's not valid anymore. But if you don't do this, this f points to this, wherever this f is pointing. So any change to that makes a change to this. So this is all I need to cover in the first part. Now I'll see you in the next part. Thank you.